So we are back on calculations on transformers, and we have example 2 over here. So today example 2 is going to give us a question about how to calculate the efficiency of a transformer. So let's listen to our question and see how we will go about it. So we have what? 11,000 stroke 230 volts 150 kVA single phase 50 hertz transformer, which has a core loss of 1.4 kW, that's kilowatts, and full load copper loss of 1.6 kilowatts. Okay, the CU here means the copper loss in the transformer. So the question is telling us to determine the kVA load for the max efficiency and the value of the max efficiency at a unit. Okay, so when the power factor is at unit, we should calculate the kVA load for the maximum efficiency and the value of the maximum efficiency. And the B is telling us to do what? To calculate the efficiency at half full load when the power factor is 0.8. So the first thing we have to do is to write our data. So our data is the kVA, which is the apparent power given to us in the question is 150 kVA, the apparent power. And the ion losses, that is the core losses, which is always constant. There can be a variation, but here is a constant loss for us, which is 1.4 kilowatts. And we have the full load copper loss, which is 1.6 kilowatts. Okay, we have our frequency to be 150 hertz. We have the frequency to be 150 hertz. We can choose to write the primary and the secondary voltage, but to our calculation we will not be needing that, so we can choose to write it whether we like it or not. So let's see what we have to do first when we are starting with the calculations of the efficiency. So the A is telling us to calculate or determine the kVA load for the maximum efficiency and the value of the maximum efficiency at unity. So unity means 1. Thank you. Let's continue. So A, as I already said, to determine the kVA load for the maximum efficiency and for the maximum efficiency at unity power factor. And the first thing we have to do is that the system told us that the primary and the secondary voltage, but to our calculation we will not be needing that, so we can choose to write it whether we like it or not. So let's see what we have to do first when we are starting with the calculations of the efficiency. So the A is telling us to calculate or determine the kVA load for the maximum efficiency and the value of the maximum efficiency at unity. So unity means 1. Thank you. Let's continue. So A, as I already said, to determine the kVA load for the maximum efficiency and for the maximum efficiency at unity power factor. And the first thing we have to do is that the system told us that the kVA that we have in the question, which is the 150, is a kVA at a maximum efficiency. That doesn't mean the system is on half load or full load. Okay, good. So we have to calculate for the kVA at the full load by adding the losses to the equation. That's what we have here, calculating for the kVA at maximum load. Okay, or the maximum efficiency of the maximum kVA. So it's equal to the kVA of the full load, okay, multiplied by the square root of the the iron loss divided by the copper loss. That's what we have here. What is the kVA? The kVA is 150 at full load times the square root of the iron loss. The iron loss divided by the copper loss, which will give us that's 140.3 kVA. So this is the maximum kVA of the efficiency. So we have our maximum efficiency of the kVA at full load. That's the 140.3 kVA. So now that we have our maximum kVA at the efficiency of the efficiency, we have to look for the efficiency maximum efficiency. By finding that, we have to multiply the iron loss by 2. Okay, after that we will multiply the output power by the power factor, and we know that the power factor is the PF is equal to 1, because it's unity. So we are multiplying 2 by the maximum load, because we want to know the maximum efficiency. So we are multiplying 2 by the iron losses. That's 1.2 times 2. That will give us 2.8. Good. So now let's calculate for the maximum efficiency. So the maximum efficiency is equal to the output power over the output power plus the losses. Okay, plus the losses. So that is what we have here. 140.3 divided by 140.3 plus 2.8 over here. So that will give us the maximum efficiency. Okay, when the power factor is 1, that's 98.04%. That is the maximum efficiency when the power factor is at unity or 1. So let's try to see the B. Calculate for the B, which the B is telling us to determine the efficiency at half load half full load when the power factor is 0.8. So now the power factor is not 1 again, it's 0.8. So now at half load we have to divide the apparent power, the kVA, by 2 to get the half of the load. That's what we have done here, and that will give us 75 kVA. Yes. So then if you want to get the output power, what we need to do is multiply the power factor by the half load. That's the 75 times the 0.8. That is the power factor. That will give us 60 kilowatts. That is the output power. Okay, good. So now, after looking for the output power, let's try to find the copper loss. After that, we find the total of the losses, so that we'll put in our equation. So the copper loss in the question was 1.6, but now we are talking about half load. So we have to divide the copper loss by half being squared. So the copper loss at half load is equal to the full load copper loss times 0.5 square root. So we have to find the copper loss for the half wave, which is the copper loss times 0.3 raised to the power 2. That's 1.6 times 0.25. That will give you 0.4 kilowatt. So that is the copper loss for what? The half load. Okay, so now let's try to find the total for the what? For the losses. Now we know that the iron loss is a what? A constant loss. So now that we are finding the what? The half load loss for the copper loss at full load, no, you have to also find the total of the losses in the system. That's what we have here, the 0.4. That's the copper loss at half load plus the constant loss, which is the iron loss. That will give you 1.8. Now let's put in our equation that we know that finding the efficiency, we have to what? Finding the efficiency, we have to know that we have to get output power divided by the output power, then plus the losses. So now we had our output power, that has to be the 60. So we will put in the equation the output power, you put it in the equation, the output power 60 divided by 60 plus the losses, which is what? The total losses. The losses of the copper at half load and then the losses of the iron at full load. So that's what we have here, and what is equal to 60 divided by 61.8. So that will give us 97.09%. So the efficiency of the half full load is what? 97.09%. Thank you very much.